Hello and welcome. Today we are going to take a case called Give Me a Hand by Tim Froelich. Another new case offer in the MEWC circuit, and let me tell you, this one hit me right in the weak spot. I hope to tell you more about it later, but let me just read the instructions here. In this case, you will be playing two different one-player card games. For levels 1 to 3, you will have a hand with 12 cards in it. Questions will increase in difficulty with level 3 being hard. And as we see in the case, we have 12 cards in every level there. For levels 4 to 7, we'll focus on one-handed solitaire, a popular road trip modification of the classic card game Solitaire. Level 4 will start with the new rules. Level 4 will be easy, with the difficulty increasing to very hard for level 7. Good luck. Alright, so you'll see how this works as we move along through the case. But let's go ahead and let's give this a try. On the actual competition, I didn't score very well because, like I said, this one is probably my main weakness as a player. But let's give this a try here and see how long it takes. Here we go. All right, level 1. To play the first game, you are given 12 cards from a standard 52 card deck. Each of the 12 cards is unique. How many cards of the given suit do you have in your hand? And here you have the table where you have the suit name and the symbol. Let's go ahead and turn it into a proper table here, shall we? I'm going to call this table suit. And we're going to go name, key, symbol. So now if I XLOOKUP these in suit name and return suit symbol, and because we have that one blank in there, I'm just going to add this blank in there for that one row that we get the symbols. And now to get the answers here, we're going to prepare the right side of all of these cells because the right side contains that suit, right? Do they equal this suit here? Now what you see what I've done is I've added this equal sign, so it'll give me true and false. This double negative will turn that true and false into 1 and 0 respectively, and the sum will add up all of the 1s and 0s together. So that will tell me how many cards match that condition I've set. So now I'm going to paste this across all of the levels and they will all match up. Level 2. Now for the given 12 cards in the hand, what is the total value of the cards? Each numbered card is worth the corresponding number of points. The value of the face cards is provided in the table to the right. NB, these card values will be used in all of the remaining levels. Alright, so let's turn this into another table again. We will call this table, I guess values, right? I mean, that's going to sound weird as I type this out, but as long as I remember it, it should work. All right, now to find the, let's see here. We're gonna do a let statement. So we're gonna let cards be, these are my cards. We're gonna let faces be, so we want everything from the cards before the suit. So I'm gonna say left cards, and it's gonna be the length of the total cards minus 1 because the suit's on the right. So if the length of the text is 2, we want 1. If the length of the text is 3, in the case of the 10 diamonds, we're going to want 2. So that's going to be our faces there. Now, the calculation, here's a nice little trick I like to play. So when the faces are 2 to 10, that's just a number. So I'm going to put, faces times 1. When it's a number, that's going to work fine, but when it's a letter, it's not. But when it's a letter for this, we can look it up in this table. So if it's not working, we're going to XLOOKUP faces in values name, returning from values points. And if I enter that, that should not work. Oh boy. Okay. It looks like the numbers worked, but the XLOOKUPs didn't. So let's see if we can figure out why. Oh, we're looking up a name. We should look up in key. That's probably why. There we go. That's all working out nicely. Wrap all of that in a nice sum statement. And now our answers are going to match the answer key there. Excellent, excellent. Let's go to level 3. This is the hard level for the first game. For your given hand of 12 cards, you might have up to 4 sets. A set is defined as a sequence of either 3 consecutive card values in the same suit, or 3 or 4 of the same card value across different suits. If a card is used in one set, it can't be used in another set. Aces are high but not low, i.e. aces could only form a set of, let's say, Queen, King, Ace, but not a set of Ace, 2, 3. How many points are worth the cards that comprise the sets in each of the hands below? The hands are calibrated in such a way that every single card can be part of only one set. And I think that's going to be key. So when I did this case live, what I did was I created, let's do a new sheet so I can run a data table, and let's put this in here. The way I did this, run my runner here, there we go, is I created a little lookup table of all the cards. So do I have suit symbol? There we go. So that's going to bring up all of my suits. And for all the cards, we got ace, queen, queen, jack, and then we'll go 10 to 2. That should do it there. Whoops. 10 to 2. Excellent. All right. So now we have all of that. Now I'm going to create a table. So we get all of the card faces and all of the card suits. That's a very nice looking card table there. What I'm going to do right next to it is I'm going to do a count if. So do these cards exist in that card table? And what you're going to find here is when you look at all these ones and zeros, now everything's going to line up very nicely. So you see here we got a row of 3 ones. That means we got 3 of the 4 cards in there. At the same time, we got 3 ones here, which means we have the ace, king, queen of spades, which is another set that we are looking for. So to get, let's get the points here first. That will help us determine how many points we get from this run of 4s there. So the points are going to be, let's see, let faces to be that. And then remember, we have if error faces times 1, x lookup faces in value, values, key, return values, points. So that will then give up, all right, that returns that very nicely there. And then to determine whether we get any points, remember, we need at least 3 to score points. So I'm going to put all of this in a biro, so I only have to type in the function once. And here's how we're going to do this. So if sum of x is less than or equal to, or no, just less than 3, then I want to return 0, otherwise return sum of x. So that, if I just hit enter there, so see, we're only going to get 3 in that one, and then we can multiply that by the values we looked up there. So now we're going to get 12 points for the 3 4s. That's excellent. Now below here, what I'm going to do is I am going to bring that together. So see, we're going to get true. So that means all 3 of these numbers are a hit. Just bring this around here. In fact, let me turn this into a number just to keep it consistent and make it easy for me to see. Is that the bottom? Oh, that is the bottom 3. That actually lined up very nicely. So let me just once again do another biro sum. Whoops. Get the syntax in there, right? Oh, that's not a whole array. I can't just use a hashtag sign there. That's fine. We'll just highlight the whole array then. All right, so we get a 1 there, which is what we want. And then, oh, I just realized that biro is probably not going to work with the way I want to do this formula. So instead, let's just sum the row. There we go. Because the reason why is now I'm thinking what I want to do is I want to multiply that by the sum of these 3 numbers there. There we go. Move that over here. Does that still stick? Yes, it does. All right. So now we have all the points for all the sets in this column. I'm just going to simply sum that column together. 38. That matches my example. Let's see if this model works. And yes, it does. Excellent. All right. So now we get rid of the first game. Let's take a look at the second game, level 4. Now, since you feel confident in your card abilities, you start to play a game of one-handed solitaire. In order to start this game, you have the entire deck of 52 cards shuffled together, and you draw a hand of 4 cards. If the first and fourth card have the same value, discard all the 4 cards. If not, but the first and the fourth card are the same suit, discard the second and third cards in your hand. How many points are worth the cards that you've discarded? The answer should be 0 if no cards were discarded. Okay, so we have 2 tests here. Those are the 2 tests. Let's just go ahead and call them test 1 and test 2. So test 1 is if the first and fourth card have the same value. Now, when you're testing for a value, there's a nice little trick. You can just simply use left. And the reason why you can do this, and you don't need to pull out, let's say, for example, the whole number 10, is because the 10 card is going to be the only one where it has 3 characters. It's also going to be the only one that starts with the number 1. So you can test only the left side of this cell to see if that matches, because it's only going to match another 10. So here we see that the king and the 4, they don't match. The K4 won't hit him, right? But if I do right of this cell equals right of this cell, that will hit. So you see we got a true in there. So it's going to be these middle 2 cards that we need to get the values out of. So let's do, let's just get the value of all 4 cards. Okay. And I want to see if I can copy this value formula somewhere else. I think this is the part I could copy. All right. So I needed faces. Okay. So let cards be these 4. Faces be left cards, then cards -1. And then that is a formula to get how many points. Is that going to work just copying and pasting? It did. Very nicely, very nicely. All right. So now 2 discards. So if it is true, it's all 4. So it's going to be sum of all of these times if that is true. Or if it is the second one, it's going to be the middle 2. So we're going to sum the middle 2 times if this is true right there. And my parentheses are a little bit off. Actually, I just don't need these outside parentheses, do I? So we get 6, and that's going to match. Let's copy that for all of these questions. And let's see if all the rest of these line up. There we go. Excellent. All right, let's go to level 5. Following the rules of one-handed solitaire, either 0, 2, or 4 cards are discarded. For level 5, return the larger combined value of the 2 piles, either the cards kept or the cards discarded. Okay, this is actually going to be very quick then. So I'm going to take this, because that whole formula will still work. We have a 2 discard value of 6 there. To keep is going to be the sum of all of these values minus what we've discarded. So there we go. Do we have 6 or do we have 17? And then what we just want the larger combined value. Okay. So by row, this one I can use a by row function for, because we're going to look at these 2 numbers and just look at the maximum value between those 2 columns. Excellent. Level 6, let the turns begin. Let's start a simplified game. I'm going to guess simplified has a secret meaning. 12 cards are dealt. See shuffled card sequence for each game. 4 in the hand and 8 in the deck. Your hand will consistently remain at 4 cards. You evaluate the hand and discard the cards according to level 4 rules, okay? Then the next cards from the deck from the side, explained below, are added to your hand so that there are always 4 cards. If 0 cards are discarded, then the first card in the hand is shifted to the side, away from the hand, but is not discarded. 1 card from the deck is added to the right side of your hand. If that new hand of 4 cards fits the discard rule, before you draw cards from the deck, you use the cards that were put to the side according to the sequence of which was the last to be put on the side. Side cards are introduced back on the left side of the hand. The game is played until all cards in the sequence or deck are drawn. See example 6 for details. What is the value of all the discarded cards in each game? All right, now let me tell you this. This is where my weakness really came out. It's this whole rule on top of rule on top of rule on top of rule. I struggle with games like that. I probably spent hours trying to dissect this to try and figure out how to get a model to work. I'm not going to explain all of example 6. If you want, you can pause the video here. You can take a look at it. But let's go ahead and see if I can model this whole thing out. So once again, I'm going to get a new sheet here. We're going to call this level 6. Copy that, paste that into there. Let's see, X look at that. All right, so we're going to have several piles to start with. Let's do turn. And because we have 12 cards, I'm going to start with 24 turns. Let's make it a nice round 25. I'm trying to find a number that I don't think this game will exceed. So I'm going to start with 25. We'll see how that goes. Now we're going to start with what's going to be left in the deck. So I'm going to call this deck. And let's just do 12 cards of the deck. So deck 1 to deck 12. Let me just smooth this up because this is going to get very hard to see very quickly. Column width of 3. Here we go. Get a nice big grid going on here. And here's going to be my opening. So I'm just going to put the whole deck into there. Now after we get the deck, we need to figure out what's in our hand. Now there are 4 cards in the hand, so there's my 4 hand columns. Then the test. Now I'm going to count this as looking for 3 tests. We have the first 2 tests that we saw in level 4, and then I'm going to say the third test is when neither of those 2 tests are hit. So I'm going to call that test, and we're going to have 3 tests. All right. Now remember, it said that there are some cards that are going to be discarded and some cards that are going to be simply put to the side. So I don't think we're going to need 12 columns for this, but I'm going to put 12 columns for this, just so that I can make sure I can fit them all in here. Just in case I get a crazy game where I put all the cards to the side. And I'm going to put this card. A sequence of 12 there. All right, so now we got everything out there. These are all of my columns. So I'm just going to make everything nice and pretty and centered because otherwise I'm going to freak out. All right, so in the first turn, my hand is going to be the first 2 cards. So let's take the first 4 cards there. All right, now the test. Remember, test 1 is whether the values are the same. So we need to see if the left of the first card equals the left of the second card. Now, because I'm working with these small columns, I'm going to turn these from true and false into numbers. Whoa. There we go. So that is 0. That means false. All right, test 2 is whether the suits are the same. So that's going to be whether the right side of this card hits the right side of that card. Okay. Is that false? Oh, I hit the wrong cell there. There we go. Now see, that's a hit, so that's going to be a true. And test 3 is when both of them are false. So that's going to be, and these 2 cells are equal to 0. All right, good. So we get a hit on test 2. Now, the side one. A card is moved to the side only when test 3 is true. So we also need to consider that it's going to be put on top of the rest of the side cards. And the way to do this, we need to be very careful about the order. I think the order that I like to go with is to put this one on top of the current pile. So let's do this. Let's do side H stack this pile, and if this is a 1, then we're going to add this card. Otherwise, we're going to add nothing there. Now what that's going to do is that's going to give me an H stack with the blank cell. So I'm going to take on top of that, I'm going to filter all the blank cells. So I'm going to filter side where side is not blank. But if it is empty, I want a blank cell. Now this is going to look very confusing, but the reason why I'm going to do it this way is because if I don't include this, what do I do if there is no filter? If it is empty, it's going to return an error, and errors are going to break my formula. Now in future iterations, this is going to help filter it out, so it will continue to work through. I know it looks weird because I'm saying get rid of all the blanks, but return a blank, but it will work as you're going through iterations of it. So there's going to be nothing in here first because once again, this one doesn't hit. So this side is going to be empty. That's fine. Now let's take a look at the discard pile. So if, actually, let's start with H stack. Actually, let's discard. Let's start with the current pile there. And in this one, the order is not going to matter. As long as the card is in there, then it's going to be counted. But I think let's start with H stack discard, and then if this is a 1, then we return all of them, right? So we return all of them. If this is a 1, then we only return the middle 2. Otherwise, we return nothing there. And then I'm going to do the same filter as I did before. So I'm going to say filter discard, where discard is not blank, but if it is empty, return blank. You can't include a parameter or let function without defining its calculations. But oh, I see. Okay, yeah, I see. This should actually go into there. Oh, discard. There we go. Okay. So that works there. So right, so because this is one is true, we're only taking out these 2 cards, which is what we've done there. Excellent. And now what's remaining in the deck is going to be the easy one. So I'm going to filter out the deck, whenever the deck is not in the hand. So I'm going to count if the hand is in the deck. If it is in the deck, then we should take that out. So that's going to be equals 0. So that's how many cards are remaining in the deck. All right, so I think you got the rules for how to take something to the side, how to put something in the discard pile, how to put something in the deck. Now the tricky part is calculating the hand. And this is probably the part where I got stuck on the most. The key thing to remember, I think, is these tests. Keep everything centered around those 3 tests. So let's go ahead. Let's see. We're gonna H stack. Actually, you know what? Let's center around if. So, if test 1 is true, that means we took all 4 cards out. We are going to actually let's draw. If this is true, means we took all those 4 cards out, then we could take up to 4 cards from the side. And because we draw the side going from right to left, but it only goes left to right, we need to reverse it. So I'm going to put 4, 3, 2, 1 in there. And then the rest of the cards could come from the deck. Excellent. Now there's a lot of blank cells. I'm going to run that filter format here, or filter formula here in a minute. So that's what we do if the first test passed. If the second test passed, then we could only draw up to 2 cards from the side. So we're going to H stack this card, followed by this card, followed by the deck. Right? Oh, wait, no, sorry. This card followed by this card, followed by the 2 cards that are still remaining in our hand. So that is these 2 cards there, and then the cards from the deck. All right, now if this is equal to 1, so one of those must equal to 1, right? Then what's going to leave is we're going to H stack these 3 cards, because this first card moved over to the side, and then a card from the deck there. All right, so those all represent the orders that the cards could go into our hand. So we're going to only take 4 of those cards. So I'm going to put this in a take, but I'm also going to run that filter that we saw before. So filter, draw, where draw isn't blank, but if it's empty, return blank. And we are going to take 4 cards from that draw. I think that worked. Wait a second. Oh, that did work. Okay, so the king came over from there. The 6 came over from there. So now we bring the deck down. Okay, we took 2 cards from the deck. We have nothing in the draw pile. We bring these down because these are the rules. Okay, same test applied. Side pile. There's nothing in the side pile. 2 more cards in the discard. All right. Now here's where I'm going to get nervous. Now errors will come up. I'm expecting errors to come up. But what I'm hoping is not that. Okay, the calc error. Oh, it might be this one. It might be this one. Yeah, because I did a filter, but I forgot the if empty. That did work. Okay, so this is what I was expecting, because sometimes the hands are now starting to get to be 3 cards. Ooh, this should not be as large as it is. Oh, cards are not being taken out of the side. Right. I forgot this part. Cards could be taken out from the side. You see, they're all coming back in, and that's really messing things up. So, when do cards start coming back in? This is where cards really come back in. And so, what I need to do is I need to filter them out. And how am I going to filter them out? I think the way I can do it is, I think I could filter them in here. Let's see. Filter this, where count if in here from that row is 0. So that should filter them out from the previous pile. So right, so I get a jack. Good. That's what I'm looking for. Let me put that formula all the way down. Okay, I think that's getting where I'm getting to. So the game is stopping here. We only have 3 cards in our hand. We can't draw anymore. So that's where the game should stop. So let's do stop question mark. And let's do count A for our hand is less than 4. If it's less than 4, that's where we stop. We are going to stop there. Excellent. So what I want to do now is I want to see what's in my discard pile when we stop. So I'm going to X lookup 1 in this stop column, return whatever our discard pile is there. That's going to bring that. There's some zeros. Let me just quickly trim range that. Probably not necessary, but that's going to make my life easier. All right, then we do the formula for the face value, which I believe I should have somewhere in here. Okay, there it is. Okay, so here's what I'm going to do. Let cards be that, faces be left cards, and then cards -1. And then I'm going to bring this formula from my previous level to get the face value of the cards. Excellent. Let's sum that all together. I think my example key was, I forgot. I got 49. What was the example? Oh, 49. Okay, that's good. All right, let's see if I did this correctly. Am I getting errors? I am getting errors. Oh, let me take a look at this one. I bet what it is I have no discard pile. Right. So, I think what I just need to do here is what I could do is something like this, but I worry about doing something like this because if there's an error somewhere else in my formula, I'm not going to see it when I run the data table. So like here, I'm getting some other errors in my formula. So I need to take a look at where these errors are. Let's take a look at 102 and let's just dissect this and try to figure out where my error is. So that's a miss, that's a hit, so those two come out. They're not coming out properly, are they? No. Oh yeah, so it should be 410 on the left. Oh no, the 2 comes in. That's a miss, so the 2 comes back out. Okay, that's right. That's right. Let's see. This is a miss, so we got 8, 8, 5, 10. That is a hit. So we should have 4 and 2 coming up. Yes. Oh, wait a second. Oh yeah, the middle 2 cards came out. Okay, that did work. That did work. So the 4, that's a hit. 8 and 5 went out. 8 and 5 is there. So we have 8 and 10 stay. Wait a second. Okay. Do they move to the right or do they move to the left? I think they should move to the left. Oh, I think that's what it is. All right, so I think what it is I need to keep the hand in and then bring in the cards from the side? No, because the cards from the side go into the left side. That's right. The cards on the side go into the left side. I think the cards from the draw go into the right side. Is that how I have this set up? Yeah, that's how I have it set up. That's how I have it set up. Okay. And then, let's see. So there's no hit there, so the cards get shifted. We bring a card from the draw pile. We have a hit there. So these 2 cards come out. Those 2 cards stay. We bring in 2, which is our 6 and our 10 there. We have a miss. And that's where we end. Okay. Okay. Let's see, this is where things get tough. What is missing? I'm going to take another quick look and then I'm going to look back at my previous solve here. I don't think it is this, or if it is, it's just I got something small. So we're bringing in the sides in that order. So let's see. We'll bring in, let's say for example, the 4. The 2 comes in first on the left, yes, the 4 comes in after. Yes, so that's right. That's right. All right, let me pause this video. Let me take a look at my key and let me see what's wrong. All right, so looking at my previous case, what I think it was, remember I mentioned earlier, I got to get this order right. Well, apparently I did not. What I need to do is I need the new card to come in on the left side. So that should be coming in there. And this one is... Oh, okay. So this one doesn't close yet. Right. Okay, it closes over here. Right. So you'll see what'll happen is that these cards in the side pile are going to be in a different order. You see here? So this 2 is always going to be the last one that's drawn out. Whereas, let's say here, this queen gets pushed out, but then later here, I believe the queen comes back with the 6. So that should have been the problem. Let's see now if these answers match. Right, and they do. All right. So keep in mind of that. Keep in mind of that. Very tricky case. All right. Level 7, time to double the fun. In addition to your 52 standard deck, your cousin gives you their 52 card Crazy Cards deck. There are 4 additional suits as shown in the table on the right. However, 104 cards is way too much, so you're only playing with 24 cards randomly drawn each time. What is the value of the discarded cards in each game? So this is actually exactly the same as level 6. The only difference, well, there's only 2 differences. One, we have 4 new suits. That's not a problem for us. The harder one is that we now have 24 cards to look at instead of 12 cards. This one is a little bit trickier, and all this means is that we need to expand our model to include a 24 card deck instead of a 12 card deck. So I'm going to take my same model here, and I'm going to show you how I'm going to do it. Now there's a couple of tricky points. If you add columns in the right spot, so do you see I'm adding them here in the middle, these should have minimal or no effect to your formulas. So what I'm doing is I'm adding 6 columns twice. That is the additional 12 columns that I need to fit all of this in my model. Hands don't change. A hand is always 4 cards. Tests don't change either. The sides is what needs to be expanded. I need to be careful because remember, in the formula for my hand, I'm referring to these cells individually. So I don't want to add them there. Let me just go ahead and add them here. So that's 6 columns once, 6 columns twice. So now we can expand that to 24 cards in the side deck. Same thing with the discard pile. This one I can expand anywhere because I'm not pointing to any of the individual cells. Is that 6 or is that 7? That's 7. That should be 6. 1, 2 there. We're going to now change this to 24. And then when I look up example 7 here, I need to change this from ending at R to ending at column AD. And I'll put AD there. All right, so now what you see is that everything should be lining up nicely. So we go to the 24 card deck. Our hands are still calculating. Because we have more cards, we're probably going to need more turns. Let's double the number of turns as well. And let's go ahead and copy all of this down to our discard here, all the way down to the 50th turn. All right. And so what that's going to mean is that this XLOOKUP is going to need to change as well. So instead of ending at row 70, we're now ending at row 95. So let's change this to 95. This one as well to 95. All right. So now I get 59 points to finish this hand, 59 points in the example. That makes Ben happy. Run. Oh, wait. Oh, I didn't fill that down. Oh, that would have been bad. Let's fill that down. Okay, there we go. Now we should be able to run our data table nicely there. Okay, and let's see if these points are lining up. Excellent, they do. So yeah, so when we get the model built right for level 6, it translates very nicely to level 7. Let's take a look at the bonuses. Bonus A, using the level 2 rules, what is the total sum of a full standard 52 card deck? Well, if we look in level 3, we calculated this points for a single suit. If we just multiply it by 4, that should be all the points for the full deck. If I don't include an ampersand in there. Why did I include an ampersand in there? That makes no sense. 364 points, and that checks out. Bonus B. Which card is not included in the 20 hands featured across levels 1 through 3, excluding the examples? All right, so to do this, the unique function will work very well. So I'm going to compare those 3 levels against this set of cards that are created in level 3. So we're going to actually, I need to V-stack them so I get all of them together. So that's my original deck. We're going to take a look at all the cards in level 1, all the cards in level 2, and all the cards in level 3. So that's my whole stack of cards. Now this unique array, the third parameter is exactly once. Return items that appear exactly once. In this case, that's going to mean the cards that are in my original deck. And it should give me the one card that was not in the levels. Bonus C, how many unique hands of 4 cards exist in a 52 card deck? The order of cards is important in this game, i.e. the answer is much more than 270,725. Now this is a classic permutations, a classic statistics problem. So classic that Excel has a function for it, permute. We are getting out of 52 cards, we're choosing 4. That's going to give us the answer if we use the function this way. Another way to think about it is simply we can choose one of 52 cards first, one of 51 cards second, then one of 50 cards, then one of 49 cards third. We should get the same answer there. Bonus D. How many of these combinations, as found in bonus question 3, will allow the player to discard any number of cards? Now, if we think about how we just did it the second time for bonus C, we're going to take the same logic and apply here. Now, the tricky part to this, I think, is like, well, what if you draw a suit or the same number for the second or third card? That's going to affect the fourth card. So the way I'm going to think about it is, let's change the rule slightly. Instead of the first and fourth card needing to match, let's say the first and second card needing to match. So once again, we have 52 cards to choose from at first. And then if we want to hit the same suit, we have one of 12 cards to choose from. If we want to hit the same value, we have one of 3 cards to choose from. So I'm going to put 12 plus 3. After that, we need one of 50 cards because this would have been one from our set of 51, and then one of 49 cards. So we should have 1.9 million combinations that we could choose that will allow us to discard any cards. Bonus E. Across all game numbers of level 7, excluding the example, how many cards were discarded? So in bonus E, or in level 7, I should say. Actually, let me take a look at the points in level 7 because I believe there were no 0-point hands. So in every game, there was a card discarded. So what I'm going to do back here on my models, I'm going to change this up a little bit. And I am going to, let's see, let me just put this out there. Why do I have a 0 here? Oh, that's why I have a 0 there. And then my final is going to be columns, cards. Basically tell me how many cards are in the discard pile when the game ends. Right, I was worried about that. Oh, that's because this column 0 is outside of the let statement. So this needs to be inside the let statement, which I believe needs to be right there. No, it is not. All right, let's take this if error out because we're not going to have an error. We don't have any 0-point games. That's going to be clear for me. The let is the red parentheses. Is that where that goes? Yes, okay. So 6 cards in the example. Let's run through all the other games there. So I see we have 266 cards discarded. Let's put that in there. And there we have it. That's how you solve the Give Me a Hand case from Tim Froelich. Very nice introduction, Tim. Again, a little bit on the hard side. You've now gone into the list of creators where if I see your name pop up on a case, I am going to shudder. Right. So just a couple of notes here. First off, level 3, you probably saw that I had an easy way to solve this. I will say, though, that what really helped me is that the card values, there's only going to be 3 cards in our card value. If there were, like, for the consecutive cards, if there were 4, if there were 5, that's going to be a much harder model. Unfortunately, I didn't have to consider that. So, like, all of these would have to be 1, for example. Level 6 was the doozy. This was the tough one. And so many hours were spent trying to figure out, okay, how do I model when this card comes in? How do I model which cards come out? How do I model, when all the cards come in, but I want these 2 sides? What if there are fewer than 2 sides? I need to pull the rest from the deck. That one just took me so long. And I even had to watch Hayden's video, which really helped a lot when he introduced his reverse lambda. I think that's what really keyed it in for me. It's like, I can't just pull the left here. I need to bring them in reverse order. And fortunately for this case, because we're only ever drawing 2 or 4 cards, I could just put that in manually. So it's like 1, 2, 3, 4, or 1, 2 there. But you see, I did get tripped up because once again, the order for this side pile was really important. That's what really tripped me up. I had the wrong order, and that's why the wrong cards were coming out, and that's why the wrong scores were being calculated there. But nonetheless, excellent job with this case. I will also note that I think that using these hollow symbols for the red cards was slightly intended to break lambdas, because I know some people hard code these symbols into their card lambda. Of course, there's an easy way around it. You see, you could just work with the symbols, or you can use like an X lookup table, bring like your full card symbols out there. But yeah, either way, this was a really great case. I am looking forward to more. Thank you so much, Tim. Thank you so much, MEWC, for bringing this out. Thank you so much to all my viewers for watching this channel. If you like this kind of content, be sure to give me a like and subscribe, and stay tuned. I try to put out one video of an Excel esports case every week. Take care, and I'll see you for the next one.
Will Vegas be her new peak? It's the Excel.